start and see what's going on here. Alright, so today I'll be working on shared memory. That's just a continuation, kind of like a lab for understanding the Linux kernel. This is where I'm gonna write something into memory, and it's gonna have a key, and whoever has the key to that memory section will be able to open and then read whatever is stored in that memory segment. Alright, so I have two classes here, read.c and write.c. I'm gonna open maybe write.c here. I'm gonna open write.c here. And I'm gonna use it to write, and here the open read.c here. I'm gonna be going in between classes. I'm new to Zilage, so it will be a little wonky moving around this, so bear with me. Okay, I'm gonna start here by defining a macro. Maybe I'll just call it, the macro is just gonna be error, right? I want to be able to print error down. I'm gonna call it a message. It's gonna take a variadic variable. I'm gonna do a do here, and do is gonna just printf, and it's gonna print a standard error, right? It's gonna print standard error whatever the message we have is, and it's gonna take the remaining whatever you give to it, right? I think it's va args. I think that's what this is, if I am not mistaken. Okay, and I would say it should exit. It should exit with ein value. Should it be ein value? Yeah, whatever. I'll just call it ein value. Now it's gonna scream, but it's fine. Yeah, it's fine. While excuse me, all 0. So yeah, that's all I'm doing here, and then I'm gonna define our memory space, what we need to give for that memory. It's gonna be called memory size, and I'll give it 1, 2, 4. And here we're gonna have our key here, and we'll call it 0600. Cool. And I'll start the program. Main, whatever this is, and we'll exit here with exit. I think it's called exit something of this nature. I don't know. Is this still capital? Okay, cool. Alright, so here we're gonna do int. We're gonna create a shared memory ID here. Sorry, I have a cold. And this is gonna be sm get, I believe. Sm get. Get is gonna take basically. Get is gonna take. I believe. What does get take? Good question. It's gonna take a key. I take our key, right? Take our key. Take our. I don't know why it's not. Take our key, Well, this is a nonsense. Let's do right again. Okay, let's see. I'm gonna take our key. Well, it's not working. That's unfortunate. It's gonna take the key. It's going to take mem size. Let's take a key. I'm kind of skeptical. So now I'll go down here, say man, SMH get. What does it take? It takes the key, the size, and then a flag. Cool, that's helpful. So I'll leave it there. Key, give it the size, right? Well, I do forget that this doesn't work. M size. It's gonna take IPC, I believe it's create, but not the complete create. And then it's gonna take the key again. Cool. All right, and here I'm gonna check if I'm gonna check if the ID is a -1, then I want to error out, right? I want to error out and then give it a message. Message is going to be failed to create shared memory. Just leave it at mem, give it at line %I, and I'll just give it a random number for now because right now things are gonna go down. Okay, and then I would have to attach the memory, right? I'm gonna attach whatever process I have to that segment. So here is gonna just be a char because I want to write like hello world to it. H pointer PTR is gonna be not 1 but equal to a char pointer, I'll point to sm attach hm attach, right? No, what does attach get? I think attach takes the ID, takes the ID, takes null and 0. That's like that, and next day I just wanna SMH pointer over here. Let's say if the char is a negative, fail to attach here. Attach, not create, but fail to attach. To shared memory, and right now I'll leave it that way. I'm gonna create our char. I'm gonna call it message. Message is gonna be equal to hello world, and it's not an exciting one, I guess. And here we're going to copy destination of this message is going to be standard. This is where getting all those libraries are important, so I'm going to just start doing that. Bang include stdio.h, and I'm going to just yank in 7j. Let's change inside here std lib.h, inside here we're going to have system IPC, because that's what we're using, and here we're going to change inside there. SC, I think it's SMH, SHM, cool. And here we're going to have change word to string. String.h, change inside here, you get string, you have uni std.h, this is for Unix I'm guessing, and then you have system slash tiny types, maybe not, I'll have, I don't know, and that, now you see most of the things are gone, most of the errors are gone. Now std standard is gonna, just gonna take into standard destination is input. Right, and the source is gonna come from whatever our message is, and then we're gonna pass it the size of the message. Cool. Right, so we get that. What are you saying? Oh, it gotta be, well, just give it that then. Okay, destination is here from, what does it say? Segmal no. Oh yeah, so from, what are we doing? I'm copying, I'm giving the destination as, is it here? Is it here, message? Yeah, right. Destination is gonna go there, and that, correct. Destination is here, and yeah, and then we're going to write to standard output. I'm going to write to standard input, sorry. stdin, this is where we do that. What are we writing? We're writing a message, correct, of size of whatever message is. Cool. And here is exit, success, I believe, correct. And I want to detach from that. I want this process to detach from whatever that memory segment is, so it doesn't hang on to it. So SHM, I think it's detach, and I'm gonna pass it this pointer, correct. Cool. Now we can go down here and let's try doing GCC compiling that. Say writer, or call it writer, write, and now we can do the CNC write /write and see. Yeah, so we have our message. Now we gotta go back and do our thing, which is where that ability to just, you know, string the H, that doesn't work here either. Yeah. Deadly signal press enter. Okay. Yeah, you see, that's what I'm talking about. What the hell just happened? Like everything is working okay here, but here, Vim preserving files. Okay, Control C. How about that? How about... Yeah, that doesn't work either. Okay, I'm just gonna quit this. Well, maybe not the terminal entirely. I do get this thing a lot. I don't know why. Let's try Zillage again, one more time. Well, we know one thing is true, right? We know we've created a file. Now all we need to do is to just create another file, right? Just create the read file. We know we have this, we have to create the read file. Cool. I'll just write this program, reader.c, and here we're just gonna have .h, and I'm just gonna yank this, let's hit 5 down, change, I'm gonna change inside here, it's gonna be maybe a stdio.h, stdio.h, gonna change that, and I'm gonna do, what should I do, stdlib.h, from here change inside, yeah. Here we're gonna have uni std.h, and we're going to have system /ipc.h, and we're gonna have a system / is that it, smh hm.h, and we're going to do an error number .h. Cool. And I would love to be able to just copy and paste that error, because there is no need for me to just keep doing that, you know. Alright, and for that we could just create a new one. It's gonna start from here. It's gonna cat whatever right is .c, right? And from here I believe I could just, actually we just need all this, right? And then I'll make a couple of changes and see that works. All right, cool. So now the changes that we need to make is this. So in the previous one we had to create. Now we're not creating anymore. All we need to do is to just latch onto something and say, okay, we need that memory, right? We need whatever is written into that memory space. And here everything looks good, but now I'll start editing. So I'm in this line, right? I want to kind of like print correct error line, so 19 minus 2, and instead of 30 whatever this is, I'm just gonna say 25 minus 2 minus 2, and that'll tell us what error we're encountering, right? And here is the good stuff. I'm gonna take this out, and this is just gonna have memory size, right? And here we're copying, so we've latched onto that memory, right? and we want to copy the message. Destination is message, and then the source is whatever the pointer was before, this pointer, and then size of that. And now we put it in standard in. Now we want to print it out, right? Wanna standard out, this one right here, and we detach. We make this process also detach, but one thing we need to add here is the ability to just do this, to destroy it, right? So we want to destroy it, don't let it linger, because then you're using memory for a stupid app. SMHCTL. SMHCTL, pass it the ID, pass it a command. The command I believe is this, and then you can have null for the rest, right? You can have null, and we are good to go. Cool. So now this is what we're doing. We're saying, hey, there is a memory somewhere that was created. It has this key, it has this size, and we just want you to have this flag 0600. I just gave it the flag. It's, you know, you can make it into whatever you want, and if it returns a -1, then you know that there was an error and it tried to latch onto that place. We create an attachment that has a what's it called, shared memory descriptor, and in that descriptor we want to check if the descriptor is also -1. If it is, then we fail. Else we want to create a chunk of memory space. We'll call it a message, and then we want to map. You see this right here, this bit right here, MSG, this is where I want whatever is in memory that I latched onto here to be put in here, right? So I'll take whatever is in this memory place. This is my source, put it in here, and this is the size of whatever this is. Then I would write whatever we just stored into this message of this size into standard output, which is in the terminal somewhere here, right? And then you detach, you kill everything, and then you exit. So now I know that was trivial. I will open two things. I think this is good, right? This is good. Okay, cool. It looks good to me for now, unless I messed up somewhere. Create a new, and this is gonna hold our write. So vim write thing.c. Cool. And I'll do it in not toggle. So you see here is write, right? And I'll do nerd toggle. This is gonna be our read. You can see this is our read file. This is our read file, and that's our write file. Read on the left, write on the right. Okay, I will compile write. You see printed whatever this message is to the console, right? And now I want to compile, because we didn't compile read before. So read or reader, whatever I call it. So I'll compile that. No error. Now we don't have a message, right? We don't have a message. We just have a chunk of space, and we say whatever was written into standard in would be written into our read. So now we have the same thing. Now if I run it again, it's going to throw an error. Why? Because we cleared that memory. All right. I'll pause. All right. Yeah, so as you can see, they're two different. We can actually, just to be sure that I am not doing something crazy, I could just say hello here, right? And go down here, and I would compile. I will recompile. C 0. Well, all right. I'll just GCC 0. I'll write, compile write, right? To write.c, run write.c. Now it's hello, right? And I'll try and run, and now you see it's hello as well. I didn't even recompile it. Now it fails again. All right, so let's say I decide to change the permission bit, right? Let's say I decide to change the permission bit. Let's see if it allows us to contact, to have access. Let's see, the permission bit is 77 in the right bit, right? Let's do that again. Well, let's do read. Hello. Let's do read and see if that is allowed. Oh, it allowed us to do it. That's cool. All right, so maybe that doesn't have an effect on it. So let's return it back to key. All right, let's change the key though. Let's change the key to just whatever. Let's see if that works. Right, let's do that. Right, hello, let's see, read, yeah. So the key, if we change the key, another process will not have access to that, but we can change the permission bit, as I think what you get to do with it. So yeah, that's it for today, and catch you next time.